I want to show you how you can make error bar graphs, because actually going through and actually trying to figure out student t-tests is actually a huge pain in the butt. So actually, let me just show you why. So if you were to type in student t-test, what you'll end up getting is, if you go hunting, a lot of you like to use Wikipedia for stuff because you're like, oh yeah, it's a good reference. Have you ever really read Wikipedia? Because most of it isn't in English. I know this is English, but it's really not made in English. So when you look for student t-tests, so you're comparing groups, what you'll notice is you'll get one formula, but then you'll get a different formula, and then two samples, and they're independent but equal size and equal variance, which means you have to know what equal variance means, and then you have to ensure that they're the equal size, and if they turn out to be unequal sizes but they have the same variance, the formula changes. And if they have unequal sample size and unequal variances, the formula changes again. So this is just going to be a whole lot of evil. So the student t-test is important. It actually is a big deal. We're going to do the cheating version, and that would be something referred to as the standard error of means, and it's going to be a graphical form of comparing. So if I were to take two groups, group 1, group 2, so this is just a Google sheet that I opened up, and I were to come up with some numbers, 45, 47, 48, 41, 40, 46, 47, 45, 44, 46. That sounds fun. Then we'll have another group. Let's go 42, 43, 47, 42, 40, 38, 42, 44, 41, 43. Okay, so off first glance, they kind of seem different. The question is, are they really different? What we can do is we need to figure out two things. First one is we need to figure out an average. So I could add up all the numbers, so 45 plus 47 plus 48 plus 41 plus blah, 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 and divide by 10, or I'm going to use Google Sheets to do that for me. So the way I do that is I'm going to create a formula. So I'm going to type in equals, which you can see right down there, and I'm going to insert a formula. The one I'm going to go for is average, and it will tell you, hey, look, let's go for average. What I'm going to do is put parentheses, and it's going to perform the function of average to whatever I tell it to. Each of these cells is a variable. So I could say I want you to start at this cell here, variable A2 or cell A2. I want you to go all the way until you reach, yeah, it sometimes doesn't like this, A11. Look at that entire range. That's what I want you to do. And it will do so. So if you realize that, oh, that 46 actually should have been a 45, it will adjust accordingly, because each of these cells is a variable, and you can just put whatever you want into it. I can repeat here, so equals average B2 to B11, and it'll give me a number. Or, if I'm particularly lazy, what I can do is I can say copy, paste, and it will do the exact same thing. Because it's a variable, the formula that I set up here is, I'm going to take and figure out the average for 10 cells that end 2 cells above. So for this first column, column A, this is the formula. When I copy it over, it's going to say, oh, repeat the same pattern, but instead of column A, I'm going to do it for column B. Easy enough. So I'm going to label this as averages. The next thing that we are going to need is, in order to figure out the standard error of means, so sometimes we write SEM, which is standard error of means. The way that it's defined is it's something called the standard deviation divided by the square root of the count, or the number of data values that you have. So in order to do this, I can break it up into a few pieces. So the first one I could do is I could say, find me the standard deviation. Standard deviation is ST_dev, so standard, then deviation. And it's A2 to A11. And I get a standard deviation. So I'll label that. I also now need the count, but now I'm going to need the square root of the count. So my count is equals count. Tell me how many I have between A2 and A11. Square root would be square root of that cell right there. And what I can finally do is my standard error of means, which will be this cell divided by this cell. Hooray! And I can copy and paste. And I have values. So I can use this, and I have numbers. What do I do with it? Well, in reality, what we can do, a standard error, if I go take an average and I go plus or minus 2 standard errors of the mean, what I get is about 95% of here are all the values, or somewhere within 95% of the average plus or minus 2 standard errors of mean. So I'm going to have 2 times the SEM. So I'll multiply that by 2. Multiply that by 2. Hooray. What I can do now is I can make a graph of this. So I'd like it to graph those two. Can I make this thing small enough so we can actually see it? There we go. So you look at this and you go, holy cow, the difference is so big, but it's because of the scale. You have to keep that in mind, that the scale is throwing things off. So all I did again was insert chart. Data, it's telling me I'm asking for it to make columns, so that's what it's doing for me, because it automatically figured, hey, maybe I should do that. The data range is A13 and B13. Thank you. For the x-axis, we don't need to worry about any of this stuff right now. So we can customize it, so we can give it names. So this is comparing groups 1 and 2. Hooray, it's been labeled. For the horizontal axis, these are groups. Hooray. For the vertical, these are their average values. Hooray. The catch is we need to add in error bars because we have to figure out a way to graph out this SEMs. Well, this part actually isn't as nice, and this is going to be an approximation. If I were using Excel, I could do this perfectly, just Google Sheets isn't there yet. So what I'm going to do, because when I look at this, is for my series, I can add error bars. The catch is they'll let me say a constant error, give them a percentile error, or no error at all. So a constant error, if we looked at the two, they're not the same. They're kind of close-ish. So what I'm curious about is that other one, which is using percentages. So I'm going to do 2 times the SEM as a percent of the average. So what I'm going to do is take by 2 times the standard deviation of the mean. I'm going to divide it by the average. And they're both about 3%. If you look, they're about 3.5%. So let's go with that. So I'm going to go with, stop that. Stop it. I talk to myself a lot. No, not the legend, series, error bars, and I'm going to go about 3.5%. And what you get are and we get error bars put in. Hooray. What we notice about this is the error bars overlap. And since the error bars overlap, what we would say is with 95% surety, meaning 95 times out of 100 that we make this claim, we're going to be right, and 5 times out of 100 that we make this exact same claim, we're going to be wrong, assuming that we get the same types of results. These two groups are actually they are actually the same. They are not different. I could have done this using a student t-test, but the math is horrible, and if we don't need to do that, let's not. That, and on the AP test, they actually ask you to do this type of stuff. So if you notice, the error bars overlap, and the result is they're the same. There is no difference between the group, even though when you looked at the pictures immediately, it was, wow, they really do look different. But when we add in error, because there's variability in everything that we do, that's not the case. Hopefully this video was mildly useful to you because you're going to need to be using it a bit or in class for some activities, and you're also going to be using it throughout the year.